In this lesson, we're going to cover graphing square root and cube root functions. Our first example says the graph of f of x equal to the square root of x, which is equivalent to x to the 1/2. And so we have an xy chart where the x's have already been picked for us. We're starting with 0 because you can take the square root of 0 and you get 0. Then, again, we're strategically using these values because when we plug in 1, the square root of 1 is 1. When we plug in 4 to the function, the square root of 4 is 2. And then when we plug in 9, the square root of 9 is going to be 3. Go ahead and plug these points in on your graph or plot them. 0, 0, right 1, up 1, and then right 4, up 2, and finally right 9, up 3. And connect your points and you get that line. So that's going to be our graph for the square root of x. And on this note page it says locator point. That's going to be the 0, 0. Your domain for this function is x such that x is greater or equal to 0, and our range y such that y is also greater or equal to 0. And it says for square root functions, the square root of x is the parent function. For our next example, we're going to graph g of x equals the square root of x minus 3. And it says, what is the parent graph? So our parent graph in this case is the square root of x. So we're going to use the graph from the previous example, and then we're going to have a shift. So it says, how does the graph of g of x shift from the parent graph? And so if we see in here we have x minus 3, that because the value that's brought in is with the x, this is going to be a horizontal shift. So we're going to take x minus 3, set it equal to 0. Let's see. We're going to take the x minus 3, set it equal to 0. And what we get when we solve for x is positive 3, so that means we're going to have a shift right 3. So if we take the original parent graph, which is the square root of x, that starts at 0, 0, we're going to move that locator point right 3. And from there, we're going to follow the same pattern. We're going to go right 1, up 1. Go back to this locator point and you're going to move right 4, up 2. You start at the locator point and then you draw your graph up to the right following those points. So our locator point for this problem is 3, 0. Domain x such that x is greater or equal to 3. And our range is y such that y is greater or equal to 0. So again, this graph, we're not plotting points, we're using transformations to graph this, and we're using the original parent graph of square root of x. We have a horizontal shift, it's shifting right 3. So you move this parent graph that used to start at 0, 0, right 3, and then from there it follows the same pattern. Your pattern for square root is always going to be right 1, up 1, right 4, up 2, and we're sufficient in using just those 3 points. In this example, h of x equals x to the 1/2, and then there's a plus 3. The parent graph is still going to be just the x to the 1/2. Which again, we're familiar from our previous lessons that this is equivalent to the square root of x. It says, how does the graph of h of x shift from the parent graph? Because this 3 is out on the end. It's not inside parentheses with the x because it's out on the end. This is going to be a vertical shift, and it's a positive 3, so it's going to shift up 3. So you're taking your original locator point that was 0, 0, and you're moving it up 3. So your locator point is 0, 3. And then we're following that same exact pattern of the square root of x. So we'll go right 1, up 1, go back to your locator point, and move right 4, up 2. And this graph is moving up to the right. Still moving up to the right, just like in the previous 2 problems. So domain x such that x is greater or equal to 0. And the range is y such that y is greater or equal to 3. Okay, this next example says graph f of x equals the square root of x plus 5 and then minus 2. So our parent graph is going to be the square root of x. This time we have 2 transformations. You're taking what's underneath the radical, set it equal to 0. When you solve, you get x equals negative 5. So because any numbers, again with the x, it's going to be a horizontal shift. Because this ends up being a negative 5, it's going to shift left 5. And then the number that's outside, again outside of the square root, that's going to be a vertical shift. So because it's a negative 2, we're going to go down 2. So we're going to take that locator point that always originally starts at 0, 0, move left 5, and down 2. And because those are the only transformations, your graph is still going to move up to the right. You're going to follow the same pattern, right 1, up 1, go back to the locator point, and go right 4, up 2. And I could keep going from my locator point over 9, up 3. But again, these 3 points are sufficient to get the idea of what the graph is doing. So your domain is x such that x is greater or equal to negative 5. And your range is y such that y is greater or equal to negative 2. In this example, we have g of x equals negative the square root of x plus 2 and then minus 4. Your parent graph is still going to be the square root of x. If you look at this equation and compare it to the square root of x, there's 3 things that have been brought in. You have the negative out in front, you have a plus 2 with the x, and then on the outside you have a minus 4. So negatives out in front, what happens is it reflects across the x-axis. And then just like in the previous problem, when it says x plus 2, you're going to take anything that's underneath the radical and set it equal to 0. Okay, so we have a reflect across the x-axis, left 2, down 4. So we're going to go left 2 and down 1, 2, 3, 4. Because of the reflex across the x-axis, the negative in front, instead of going up to the right, this graph is going to, again, reflect across the x-axis and come down. So it's going to still go over 1, but now it's going to go down 1. And then go back to the locator point. You're going to move over 4 and down 2. And so your graph now goes down, again still to the right, but it's just going down. So our locator point is negative 2, negative 4. Domain x such that x is greater or equal to negative 2. and the range is y such that y this time is less than or equal to -4. In this equation we have h of x equals negative, and then quantity x minus 3 to the 1/2, and then a plus 1. So your parent graph is x to the 1/2, which again is the same as the square root of x. To find our transformations, we're going to take that inside part and set it equal to 0. So you get x equals 3. So that's going to be a right 3. Again, any number with the x is going to shift horizontally. Any number on the outside will be a vertical shift. And then we do have the reflect across the x-axis negative in front again. So let's go ahead and list those. Reflect in the x-axis, a horizontal was right 3. And then at the end, our vertical shift is up 1. So we're going to move the original locator point at 0, 0. We're going to go right 3, up 1. And again, because of the negative in front, we're going to not shift, but we're going to still move to the right, but this time we're going down again. So we'll go right 1, down 1, go back to the locator point, go right 4, down 2. So let's list that locator point. It's 3, 1. Domain, x such that x is greater or equal to 3. Range, y such that y is less than or equal to 1. Okay, to sum up all of our transformations, it says given the form g of x equals a, the square root of x minus h, and then plus k, describe how a, h, and k affect this shift from the original parent graph of the square root of x. So the a, if a is negative, we have a reflect across that x-axis. H, you take the quantity, set it equal to 0, and we get x equals h. That's going to be a horizontal shift. And then k is going to be a vertical shift. Okay, now we're going to look at cube root graphs. Again, the front part of the notes was the square root. All your square root graphs, you're starting with your locator point and then you're moving to the right, either up and to the right or down and to the right if there's a negative in front of the square root. But now we're going to again move on to cube root functions. We'll start off again with an XY chart just to get an idea of what the graph looks like, but then after this we're not going to use an XY chart anymore. We're going to do transformations from this parent graph. So again, it's a cube root of x, so when we plug in a -8 to the cube root of -8, you get -2. Plug in -1, the cube root of -1 is -1. The cube root, plug in 0, the cube root of 0 is 0. Plug in 1, the cube root of 1 is 1. And plug in 8, the cube root of 8 is 2. So we're going to plot these points. So left 8, down 2, left 1, down 1, 0, 0, 1, 1, and then 8, 2. So this graph kind of resembles, the right half of it kind of resembles the square root, but it's a little longer and narrow. I like to think of this kind of like a snake in the grass, and then right in the middle is the locator point, 0, 0. Domain is all real numbers. the range is also all real numbers. And it says for cube root functions, cube root of x is the parent function. Okay, in this example, we're going to graph the g of x equals cube root of quantity x plus 2 plus 3. The parent graph is going to be the cube root of x. And then we have two shifts. Take what's underneath the cube root, set it equal to 0, and we get x is negative 2. That's going to be your horizontal shift. So we're going to go left 2. And then the number on the outside, the plus 3, is going to shift us up 3. So we'll move this locator point that starts at 0, 0. We're going to go left 2, up 3. And then there's no other transformations. So we're going to follow the same pattern. To the right from the locator point, you're going to go 1, 1. Go back to this locator point, and we're going to move right 8 up 2. 1, 2, 3. 4, 5, 6, 7, 8, up 2. So this is just to the right what the graph is doing. And it's going to do something similar pattern to the left, except you're going to go left 1, down 1. Then we're going to move from this locator point right here. We're going to go left 8, 2, 3, 4, 5, 6, 7, 8, down 2. Goes off the graph a little. And so here is your cube root graph. That locator point was negative 2, 3. Domain is all rails. And our range is also all real numbers. This example says graph f of x, which equals negative x to the 1/3 plus 2. And remember, x to the 1/3 is the same as the cube root of x. So our parent graph is x to the 1/3, which again is equivalent to the cube root of x. And this value on the outside is going to be a vertical shift. We're going to go up 2, and then we also have a reflect in the x-axis. And then what did we say? We just said up 2. So we're going to take the locator point, we'll move it up 2. And because of this negative, let's see, the original parent graph from the locator would go right 1, up 1, right 8, up 2. Because there's a negative in front, which reflects again across the x-axis, we're going to go, instead of going right 1, up 1, we're going to go right 1, down 1. Go back to this locator point, go right 8, down 2, and connect those points. In the other direction, we're going to do the opposite. We're going left 1, up 1, left 8, up 2. Locator point is 0, 2, and domain and range are all real numbers. In this example, we're graphing g of x equals negative the cube root of x minus 4. So we're going to take this and we're going to set it equal to 0. So we get x equals 4. That's a horizontal shift because the number is in with the x. So we're going to go right 4, and we have a reflect in the x-axis. Let's fill in the rest of these. Cube root of x is our parent graph, and locator point. So we're going to go right 4. That's going to be your locator point for 0. And reflecting in the x-axis, instead of going right 1, up 1, we're going to go right 1, down 1. Go back to this locator point, go right 8. 1, 2, 3, 4, 5, 6, 7, 8, down 2. And the opposite in the other direction, so we'll go left 1, up 1, left 8. Go ahead and fill in your domain and range, all reals. Okay, this last example says h of x equals the quantity x minus 2 to the 1/3 and then a plus 1. So parent graph, x to the 1/3. We have two transformations. This is your vertical because the number is on the outside, and this is your horizontal transformation because the number is in with the x. So this one, we're going to set equal to 0. And we get 2. So a transformation would be right 2. And then again, that vertical is going to be up 1. So from 0, 0, we're going to write 2 up 1. That's our locator point. 2, 1. And there's no number, no negative in the front, so it's going to follow the same pattern as the original parent graph. So from here, you're following just the pattern. You're going to go right 1, up 1. Go back to the locator point. Go right 8. Up 2. And to the left, we're going to go left 1, down 1. Go back to this locator point. We're going to go left 8. Down 2. And there's your cube root graph. Domain and range are all reals. And again, just remember your pattern for cube root or x to the 1/3 graphs. From the locator point, you go right 1, up 1, right 8, up 2. Left 1, down 1, left 8, down 2. And again, for your square root graphs, the pattern, we're always going to the right. You're going to go right 1, up 1, right 4, up 2.